words about myself before I start, and also sorry for the voice, like everyone knows now I'm English, and I live in a hot country, and I've also been to France recently, so either it's the first one, or the fact that I was poisoned recently by French, which is also just as likely, so I'm going to drink a lot of water and stuff, and hopefully you'll still get to hear me. So I've got a lot to get through in 50 minutes, so I have to keep up the pace, so very quickly, my name is James Mallison, and I'm a software engineer working with Trivago in Mallorca. And I love PHP. There's no tea at this conference to help with this, which I find outrageous, but that's fine. Englishman in Mallorca, and today I'm going to be talking about something traditionally you wouldn't really do with PHP originally, even though it's now definitely more capable of doing it, and that is WebSockets. So I want to talk about WebSockets and the torrents. WebSockets because it's a non-traditional way of doing client-to-server communication, and I really like doing things the way you're not supposed to. And torrents because you can do a load of illegal shit with it, which obviously I haven't done and I'm not going to do during this presentation, or during the demo I am going to do some torrents of legal stuff, which is all I've ever done, of course. So this talk is kind of the story of downloading torrents and sending the metadata of those torrents over WebSockets. So this is kind of the agenda of what I'm going to be talking about now. So it's a story of how my interest in WebSockets came to be, so there's a real use case here. How I implemented the technology for arbitrary torrenting. Now the problem here is that if you Google WebSockets tutorial, you'll typically find it involves the client, a chat application of the client sending something to the server, and then sending something from the server to another client as a result. And that's triggered by the user. So what I'm trying to show here is how I figured out how to send data from another source to the user, so it's not triggered explicitly by the user, and then hopefully you can use this if you ever want to do any sort of real-time stuff or push notifications, which I think is a hell of a lot more useful than just Googling WebSockets and finding a chat application. So I'm also going to show an architecture that I came up with that doesn't need async, so you don't need to understand asynchronous stuff in order to do this. Some of the problems I encountered along the way, a demo, or maybe two demos to show it actually working, and then what I learned as a result, and then hopefully you can go away and decide if this is the right solution for your stuff, sending push notifications and send any arbitrary data from the server to the client whenever you choose to. So the story goes that in 2012 I was at university. I was a university student, and I used to download a lot of torrents at university. Me and all of my mates would go into university, take external hard drives in because we had really fast speeds at university, and we download everything completely legal, obviously, onto the hard drives while we were there. So we put them into the back of the server in the corner, and then just leave them, because they were good download speeds. But the next step for me was to do this at home. So when I just got my student loan for the first time, I wanted to spend it on something, so I bought a motorbike, and I bought loads of beer, obviously, and then one of the other things I bought was a router. And this was before I knew what the difference between a router and a modem was. So I bought this router, I think it was an Asus RT-N56U, and had little blue flashy lights on it, and I really liked the shininess of it, so I went and bought a router. And I put it in at home and then didn't know what I was doing with it. But what I realized was, you could flash the firmware on it and install something called DDWRT. So once I'd done this, I could then SSH into the router itself. So once I'd done that, I opened up my computer, SSH to the router, and I installed the LAMP stack for absolutely no reason. So I installed PHP, MySQL, all of that stuff. And I also installed a headless torrent client. Now at the time there were two main ones, competing ones that I found. The easiest one for me was Transmission. Transmission was the easiest torrent client to install. There was also the option of plugging hard drives into the back of this router because it had USB ports, and then downloading every TV and movie show that I'd ever watched and had them automatically transferred to the hard drives at the end. Obviously I didn't do this, it's just what I could have. I just downloaded a bunch of home, that's all I did. So this was the GUI, the transmission headless client. I think you install something, apt-get install transmission client, and I think this is the GUI that came with it. Now this looks like an actual application, but this is running in the browser. So if you right-click and choose Inspect Element, then you'll see this isn't an application really in the strictest kind of desktop sense. It looks like one, but it's just a load of crap CSS with some horrible icons and stuff like that. And I just finished university at this point, so I didn't have access to all the fast download speed anymore. I did have this, and I figured, I need a job and I need to showcase my potential to potential employers. So what can I do? So I figured that this data from this Torrent client was becoming somewhere and being populated in this HTML and CSS from somewhere. So I set out to go and figure out how to get that data and kind of create my own GUI and then have my own progress bars using maybe Bootstrap framework or something, Bootstrap framework, CSS framework, have these nice progress bars with these animations and things, and I could just grab the percentage completed of the torrent and then put that on like a CSS attribute and have this progress bar go up. That was my idea. So I also needed to get that data in a standardized format like JSON or XML, and obviously I'll never use XML because it's absolutely ridiculous, and JSON's awesome, and I wanted progress bars and animations. So the first solution that I came up with, and bearing in mind I was a graduate, and obviously the first solution that you come up with as a graduate is clearly the correct one, but I ran this command here at the bottom, transmission remote, which is you give it the IP address and port that transmission is running on, and I used -debug and -l to give me all of this terrible shit here. And the only thing that I actually cared about was this JSON here and these kind of column separated things here. So this is where I figured out I could use sed and or to separate these columns here. But I also needed this JSON as well in certain parts of it. So what I did was I manually interpolated strings, brackets, and quotes to make my own JSON from all this stuff with this horrible regex to get rid of all the stuff at the top. And it took ages, it was horrible, but it worked. So I did get it working. And then that gave me this torrent information that I needed to display to the client. So that was the first solution that I did. So it kind of looked like this. Everyone knows how Ajax works. You send an Ajax request from the client to the server would perform the command line call using an exec in PHP to get this information, and then it would return the JSON to the client, and I would hold my service to do this every 5 seconds or something like that. So I was really proud of what I'd done. This was the first thing that I'd done that the university lecturer hadn't forced me to do. I did this off my own back. So I went to some of the nicest people on the planet, clearly, Stack Overflow, and said, hey guys, I've done this is awesome, what do you think? Really proud, and this is the response that I got. And as usual, the response was absolutely nothing to do with my code. It's like going in there, asking a question about Symfony, and then they go, oh, I'll try using a framework. Thanks, guys. So they said I was exposing myself and my unnaturally large amount of Ubuntu downloads to the world. So they said I needed another server, a virtual private server, a VPS somewhere else in the world that I could connect to and talk to anonymously for all these Ubuntu torrents. So Ubuntu could never see who was downloading so many things. So what better place than Stockholm, Sweden, which is where the Pirate Bay data centers were. This is the thought process that was going in my mind at the time. It's also where they were raided by the police, and I didn't think about it at the time, but I think that those were Ubuntu downloads, so that's fine. But I found a virtual private server over there, and I wanted to pay for this anonymously. So there was a petrol station just around the corner from where I live, and I'm a motorcyclist as well, so I had the helmet, the gear, everything, So I decided that I'd park my bike around the corner, put my gear on, walk into the petrol station and pay £10 and get this anonymous credit card so the CCTV cameras could even see who it was. Obviously this was for educational purposes only, okay? I didn't do anything dodgy with this shit. That's the only reason I did it. But I then connected over Tor to buy PayPal with this anonymous credit card which I got. And then that was basically, I got a VPS with the PayPal account all over Tor. That was as anonymous as I could make it. So with that, I installed the torrent stuff on my virtual private server, and then this is kind of the new data flow of how everything works. So the browser makes an HTTP request to my server SSH over Tor using an application called Torify. I think I used PHP setlib as well, where that had some secure SSH implementation or something that I really liked or needed, which would then go to the virtual private server. The virtual private server would run mine, and then it would go back to my code, and then it would run back to the server, and then finally back to the client. So I had done exactly what the Stack Overflow guys also did. I'd gone away, I'd done my research, I'd done this anonymously. So I went back to Stack Overflow and said, hey guys, I've done exactly what you told me. What do you think? And this is the response that I got. And finally, they gave me something actually useful about my code and technology and architecture. And they said, use Websocket. Great. So, why not use WebSockets? So I'd never heard of WebSockets at this time, I really hadn't. In fact, I think it was only 2011 that the RFC actually went through, so it was standardized and everything. But I went away and I did some research. And I did a lot of trial and error, a lot of hacking until the rest of this presentation is what I came up with. So I'm going to try and show you the result of an actual architecture of making WebSockets work, not just a chat application. So I'm very briefly going to skim over what you can Google really easily and go to the stuff that you have to find from many different sources. So WebSockets actually kind of hijacks the TCP connection that HTTP uses on port 80. So you make a HTTP request that's interpreted as a HTTP upgrade, and then it responds with a HTTP 1.1 switching protocol, and then from then on you have an open and persistent TCP connection, which is where it's bi-directional, so you can send information anytime. You can send information from your JavaScript client, which is really easy to do because you can click a button which triggers the event to send information to the server, which you can then respond to. Not so easy is getting the server to do something on its own and send it to the client, which is why you see just a chat application which is effectively triggered by the user from the client. Well, you have this open persistent connection that can then be closed by either the client or the server. So when the server goes down, the client is told about that, which is one of the great things about the WebSocket protocol, in that it knows the difference between and can differentiate between sending no data and closing down. So you get that, you're able to respond to that in your code. So if the server goes down, you can then keep polling it to see if it comes back up, or you can fall back to Ajax, that's up to you. And on the server, if a client disconnects, in your own code, you are told that the client disconnects, and then you can respond to that by removing the client from your internal array of connections that you want to send information to. This is effectively a kind of server that you're creating, and you'll see me do this in a little bit. So HTTP versus WebSockets, very briefly, you've got the half duplex thing where the client sends information to the server responds, yeah, that's it. That's how PHP was originally designed. But with WebSockets, you've got this thing on the server, this loop that's taking in things and sending out things. This is the event loop, which I'll go into more detail about in a bit. This is full duplex. So you can send information at any time and receive information seemingly at any time, and accept and close connections all seemingly at the same time. So quickly, what do we mean by full duplex and half duplex? Well, in half duplex, which is your HTTP standard 1.1 stuff, in a conversation, only one person can talk at once, and the other person has to listen and wait to give a response. So in full duplex, in a conversation, everyone's able to talk over each other at the same time, like PHP internals, and everyone is also able to understand each other and what each other is saying, not like PHP internals. So I mentioned event loop before. What is an event loop, and how does it work, kind of? I found this diagram online. It was really useful for my understanding. A request comes in, and you register an interest in having some data sent to you in the form of a callback. The intensive operations like database calls, I/O, all that sort of stuff is performed outside of the event loop. And then only when it is done does it get sent back in, and the callback is triggered with the result of that to give the response back to the user with that information. So this is kind of a high-level overview. I want you to keep this kind of separation in your mind now. We've got the request coming in, the event loop with all the magic happening seemingly in the middle, and then the intensive operations outside. There's three things, and then towards the end of the talk you'll see these three things, almost like you could slap this diagram on top of my diagram and see it's exactly the same. Because I drew my own diagram later. So I like this diagram. It's from embedded systems. If you don't understand, you don't need to worry too much about it. But by default in PHP, you can use stream select and watch on multiple streams, read and write streams. A stream is typically a file descriptor or a network socket that we're listening on, for it being written to, and when the stream has something on it, we read it and execute a callback. So going on to event-driven programming, which is what we're going to be doing in a little bit, we seemingly jump around when something is triggered. So even though we're seemingly in the middle of this loop somewhere else, we trigger something and then we jump to a method in our code. And I find this helpful when thinking about events. So I'm going to show you a really simple example of using PHP's process control extension to see, as PCMTL, to see how we can, even though we're in the middle of a loop, do something else. So I'm going to show you that right now. So I'm going to go through this code line by line very quickly. Ignore declare ticks, I'll come to that at the end. We're declaring this function, this signal handler. It's just a standard function. You can do whatever you want in it, and we exit. Then, because we've got the process control extension installed, we can use PCNTL or signal. And we're saying that when we receive a sig term, run the signal handler function. Sig term is minus 15. If you do a kill minus 9, that will kill the process. Do a kill minus 15, and it allows this to be executed. So you can kind of close your application nicely. We also echo a process ID, so we know which one to kill. And then we do this while loop, while true, sleep. That's it. You enter in your terminal, move this terminal to the top left, and then sleep. It just keeps sleeping forever. So then when you open another terminal and do kill minus 15, which is the sig term, it will, even though you're in the middle of this sleep call, jump seemingly to this signal handler and then execute stuff in there, even if you're 5 seconds into this sleep. That's crazy, that's really cool, right? So this works because the underlying operating system call, sleep call, is interruptible. So if you go into the PHP C library code for sleep, or you sleep, and see the operating system call that it's doing in there, and then go to the map page for that, you'll see it states is interruptible. That's why it allows us to do this. So going to declare ticks at the top, not declare tops, declare ticks equals 1 is telling PHP to poll or interrupts. So there isn't actually, some people are hating for this, there's no such thing as real time, actual real time, because somewhere eventually we're still polling for something. There will be polling somewhere, the source of the data. Anyway, so this is telling PHP under the hood that after each executable low-level function call with side effects, to poll, have we got any interrupts in? Have we got any signals? And if yes, then we're going to jump to the signal handler. If you don't declare ticks, PHP is not going to poll, which obviously has overhead with all of this, and then it's not going to execute. So that's why we have declare ticks at the top. So why am I showing this? I've already stated this, but I want to show though that even though this loop is happening, we can jump to or trigger something else. Something else can trigger something else to run our function. That's what's happening. So in event-driven programming, we can trigger an event in an already running process, or event loop, and jump to a method or some function call or something like that. So in our case, this already running process is an event loop. And here's the event loop implementation that I used for my project. So I'm sure you've all heard of React PHP. It's a set of components, primarily an event loop. There's HTTP, DNS. Ratchet is a WebSocket implementation on top of this. Now, React is a PHP implementation of an event loop that uses select calls under the hood. But this is why all of these libraries, React PHP, AMP PHP, they always suggest installing libev or libevent, or libuv if you're on Windows, but obviously not one person is going to be using Windows today, of course. And that is because they are cross-platform C implementations of an event, which are so much more faster, obviously, because C is faster than PHP. So they always suggest install these because you will call library methods on React, and if you have those libraries installed, it will transparently call those C library methods and functions if you have them available. So we're going to use Ratchet now to do something really simple. This is the beginning stages of everything getting a little bit more complicated, but it's the easy stuff right now at the beginning. We only have to do 3 things to make this whole website work. We have to create an event handler class that implements Ratchet's interface methods from a WAMP spec, which I'll show next. OnSubscribe and OnOpen are 2 of these methods that will get called for you when someone subscribes to receive some information, like torrents, and open when we have a connection open. Then you need to tell Ratchet that this is my event handler class, really easy, you'll see this, and then we run PHP index.php, which contains this code. That's it, that's your WebSocket server running. So, when something triggers an event, either the client requesting they want to register an interest in receiving some data, or the event handler is given some data to return to the client, your event handler class will have a certain method executed by Ratchet for you, like OnSubscribe or OnOpen. So this code is literally copied and pasted from the Ratchet documentation, apart from our event handler class here. That's the thing that we're going to write, which contains OnSubscribe and OnOpen. When you have JavaScript to call this, JavaScript calls .subscribe, which triggers onSubscribe in this event handler, which is where we do our sending torrent data. That's it, it's really easy. So we need to handle users disconnecting it and reconnecting. You're going to see this now, implementation time. So the WAMP spec is just a set of methods that you have to implement, that on subscribe, on close. It provides pub sub patterns and all this other stuff that you don't need to worry too much about. And then you also need a JavaScript library that conforms to this WAMP spec as well to make this happen. So here you go, here's the WAMP spec in an interface form. These are the methods that you have to implement in your event handler. So event handler implements WAMP server interface. That's it. That's all the magic that you need to do. And then it has on open, on subscribe. You just need to implement these methods yourself. And we're going to do that now. So I want to make it quite clear now that the tech stack for this is not complicated. You've got Apache and PHP, which is obviously serving you standard web pages, or Nginx if you want to use Nginx. You've got Ratchet and your event loop, which is technically kind of another server, accepting WebSocket requests and sending stuff over WebSockets. And then on the JavaScript side, you've just got JavaScript, and you've got your WAMP conforming library, which is Autoloop. That's it. So not a complicated tech stack so far. So I've copied and pasted the on open interface thing there, put it at the top, and then this is our event handler that we've created, which implements WAMP server interface. We've created this, I've closed on subscribe and on close for you, so you can just see on open. We're basically here saying that when someone opens a connection, we're storing this connection in an array of clients, and then we're calling this logger, I've noticed, and logging that someone's connected. Now what I want to make clear is that this is just a standard class. You have your own constructor, you can dependency inject whatever the hell you want, the logger, the actual event loop, whatever you want to do, it's just a normal class. What is different though is because we're not doing this in a standard HTTP context, which is where we kill the class and get rid of all the memory when we get a request response dead. Because this is staying open, this event loop, and it's sending things to this. This class, the clients, internal clients array in this class is going to grow as you add more clients, people connecting, and shrink when you remove them. So the on-close method here is just going to be the opposite of this. You're going to array search in those array of clients, find the client, and then remove it from the array of clients. That's it. That's all you need to do for on-open and on-close in this simple example. So I'm going to show you the JavaScript that goes with this to make this be executed. So I've moved this to the top, and now we've got the JavaScript at the bottom that causes this to be executed. We're opening a connection to 127.0.0.1 on port 9000, and then we're calling open at the bottom, and when it's open, the connection, we get the session object back. We'll use the session object to subscribe in a little bit. That's like literally the last step that we need to care about here. This is so simple. This is what executes the stuff on, that causes on open to be triggered in PHP. So there's a connection between these two things. This is what the interface, the WAMP server interface gives you. On open, JavaScript, on open, PHP. Easy. Moving to unsubscribe, again I've moved the thing at the top, so you can see the actual interface method that we have to implement. This is a little bit more complicated, but we're passing in the loop, which has methods on it like add periodic timer. And what we're saying here is that every 2 seconds do something, and that thing we're doing is we're making that whole command line call to torrent data. And then topic, the topic object, which is torrents, we send that data to everyone who's subscribed to it in JavaScript. That's it. That's sending the data over WebSockets now. That's literally it. We also store that timer against the connection in the internal clients array. And the reason we do this is because when we call on unsubscribe, or the client goes away from the web page, on unsubscribe is called for us, and all we do is we do an array search, find that client, and instead of just removing the client, we find a timer object and call stop on it. So this timer object has really simple methods, stop, pause, things like that. We're just storing the timer against that client, that's it. So now to make that happen, here's the JavaScript at the bottom again. The only difference here is in between the on-open brackets, we've got session.subscribe to torrents, and then every time we get torrent data back, we log totally legit torrent data, and this will happen every 2 seconds now. That's literally it. Every 2 seconds we're doing this console log. Now before I continue, I'm going to show how easy it is to run Apache and this WebSocket event loop together on the same server. Because when you make a request, it needs to know whether it's going to HTTP, so Apache, or whether it's going to your event handler because it's a WebSocket call. So I think you have either this line or one other line, you can easily Google this, proxy pass or mod proxy, and I think it's proxy pass reverse as well. This just states HTTP continues on in your virtual host like normal, and a WebSocket request goes to your event handler. That's it. Or just use Nginx. Apparently it's supposed to be much easier to do with this sort of stuff. So the high-level functionality now, before we continue, looks like this. You call .subscribe from your JavaScript, and you have your callback there, which is your console.log, which displays the torrent data. This triggers onSubscribe in our PHP. And here we store the connection in internal array of connections and start the timer against that to send information out every 2 seconds to broadcast it back to the client. We get the torrent data, broadcast it out. Topic broadcast is the thing that I was doing to do this. And then when the client calls .unsubscribe, we do an array search, and we remove that client stop timer obviously as well, and that's it. That's the whole life cycle. And then people are going to be connecting, disconnecting, subscribing, unsubscribing. This client's array is going to close and shrink and grow. So I'm going to show you a demo now. Hopefully this works. Of where I got to at this point to make this work. And I think in order to do this, I need to remove it when you go back. Okay, you can see this. This is a transmission, horrible transmission query, right? See, 2 totally legal torrents here, nothing else. And here's the code to make this work. This IO server, ignore all this stuff, copy and pasted. The only thing is, this is our event handler that contains onSubscribe and onopen, almost literally with the code you've just seen. So I'm going to start this WebSocket server. I've also got this login here just to say it's starting. And then I'm going to show you my application. I'm going to go to downloads. So I need to log in because I've got authentication on it when it was just me and my mates that were doing this. And every 2 seconds now, this information is going to be pushed to us. You see that we've got 2 Ubuntu torrents here, going to be pushed to us every 2 seconds. This is what's happening in this architecture. And then if I replay these here, so they're now playing, resuming, see how it's changed to downloading here? So we can basically every 2 seconds we're asking for this information and pushing it to the client. Still polling on the server, but we've removed the overhead of asking for all the headers and everything that comes with HTTP every time. So as you can see in the network, we have no new new requests, new HTTP requests. So we remove that. So that's the first. Well, I can do code 2.0 on targeting, which is great. So this is the first problem that I came across with this, and that problem is. I envisaged me and all my mates and everyone who wanted to do it to have their own torrents. So we'd use one torrent client, one transmission daemon, but we would store the torrent hashes and the user IDs in a database, and then once we've got all the torrent data, we'd get the user ID and filter on those, so each user would have their own torrents. That was my idea. But with the current solution, this isn't on a per user and per connection basis. Everyone who subscribes to torrents is going to get everything pushed back to them. So if you open the same page twice, not only are we going to get data sent back to both pages, the same data, we're also going to double that command line call, so it's going to be sent back double. So everyone, even the first person who didn't do anything, is going to have this information duplicated and sent back to them. So my solution to that at the time was the topic has to be a string. JSON's a string, it's just structured. So I put the topic in the topic, and then also the user ID in there as well. So the user ID was given from PHP to JavaScript. JavaScript would subscribe to this JSON string. So now every subscription would have their own unique user ID. So 2 different users, 245 and 246, would open 2 pages, and then each have this command line call done for them on their own. Problem is, the same user could still open the same page twice and then double duplicate their data for the same user. So this comes on to the second problem I had, which was authentication and this duplicate data thing, because even though this was just me and my mates at the time, one of them could easily put it out with the JavaScript variable with the user ID and then continue. I don't know why they would do that, but they could, and it's not secure anyway, because if I open this up to the world, anyone being auto-increment IDs, could change the user ID and then make the WebSocket request. So I came up with this solution which was to generate a random token on the server, give it to the client, and then we would send that token back up for the initialization of the WebSocket connection, and then check that that user ID and the WebSocket token were the same as in the database, and then change that token so no one else could do that. Now I know Ratchet has a sessions component to work with, Symfony sessions, but I wasn't using HTTP Foundation at the time, so this was my own solution to make this work. And the biggest problem that I had was blocking. So while this command line call was being made every 5 seconds, nothing else could happen. The event loop gets to the point where it makes that really shitty command line call. No one else could register their interest in receiving information, and no more information could be sent out. And this is the same for in a non-async context, because we're not talking async here and we don't need to. This is where we mess everything. So 10 people use this, we block all the time. So, and then when there's a little gap, everything gets sent out, and then there's a break, and then everything gets sent out. So this was blocking. Same goes for authentication, and checking a database is going to block as well. You know, if that query goes really slowly, you're going to block. So solutions to this are to use another process or a job queue. So the job queue, I use both. I show both next. The job queue requires a good architecture, decisions for local playing, make sure that is your worker going to have the responsibility of knowing where to send it to, or do you store that in your event queue, or are you going to put this in a database behind an API? It's up to you. So the first option is the child process, and this is where in the on-subscribe, instead of doing the command line call every 2 seconds, we start a new process with the PHP in a separate file, and then add a timer, and then we pull the standard out of this process and wait for the data to come back. Which means that the event loop can still continue, but we only broadcast this data when we get that data back. So we're not waiting for it to come back in the way that we're blocking the event loop. So this is great. The event loop can continue, but this is only on one machine. This isn't scalable, you know. And also, if you're going to do this for small projects, great. But if it's not scalable because you're spawning a new process every 5 seconds for every client, and there's lots of overhead with creating a new process, including memory allocation, file descriptors, file handlers, all that sort of stuff. Because a process is the biggest unit of execution an operating system has, so it requires the most resources. Well, so the other option is to use a job queue, and zero queue is what I came up with for the second option. You put this information right at the beginning. This is also on the Ratchet documentation. You can copy and paste this. The only thing I needed to change was the name of the method on ZMQ response. And we're saying here that anything that comes over port 5555 on ZMQ is going to hit a new method that we haven't created yet on ZMQ response. Any data whatsoever, from anywhere. So you can see now that the process can send this data in any time of worker perhaps. And then that's how you've got stuff back into the queue to send back to the user. So you're not waiting for it anymore. You fire it to get into a queue, and then the worker just does its stuff and puts it back into the event loop, to the event handler to be sent back by the event loop. So in order to do this, we find forget in our on-subscribe method. So instead of calling new child process, we just send this off to a queue. And that's it. I'm using Beanstalk here, but since I've used RabbitMQ, which is easier, and I really like it. That's the library you can use anyway to do all that. So now we've done that, we've created this new method here on ZMQ response, and this is where we simply get that data and then we broadcast it to the client. In this case, the ZMQ is actually, the worker is actually holding the person to send it back to you, but like I said, you can store who to send it back to some other way. So the higher level architecture now is kind of the same before as we start out. In our subscribe, we fire and forget into a job queue. You've got all these workers that do the job and then send it back over ZMQ to hit our ZMQ response method in our event handler, and then we broadcast that back to the client. So see how, remember that diagram at the beginning with the 3 separations that I told you about? This is you could put this on top of mine transparently and kind of see how I separated these 3 things like that. And the great thing about this is that the event loop is now the intermediary for sending data out and for registering an interest in receiving data, i.e. saying I'm subscribing to torrents. And you can have workers in Java, C#, all this other stuff, because they all implement and have 0 and Q libs. So I'm going to show you the second demo now with inter-process communication to make this work. 1, 2, bam, that's great. Okay, so scroll up. See here, this is literally a copy and paste of the stuff that you saw in the previous slide, except I've called it on terminal test. That's it. Here is the method on terminal test, and all I'm doing to make it easy is I'm just looping around all the clients and broadcasting on the topic for all those clients. That's what I'm doing. And then, this is the one line of code you need to make this work. So, PHP server, final copy. And in order to execute this, I'm going to actually go to downloads now. Stop this 2-second thing. This is a completely separate thing. Go back, and I'll test PHP, run this file, and you can see here, or maybe not, I'm going to do this really fast like that. You can see here, the response data, PHP server, I'm not happy. So this is a separate process, injecting, I like that word in this context, putting stuff back in from anywhere, and then we send that back to the client. That is how you would have a separate process, inject stuff completely separate, and get it sent to the client over WebSockets. So if you were polling, it's a C or something, and a real-time device, and you wanted to display this in a web page, and you were using WebSockets, you push it like this, you inject that back into the event loop to be the event handler to push back to the client. Okay, what about scaling? So you can either use hard proxy or something like that, which I've honestly never used, or you can kind of do this yourself with logic. In this case, I could create an API which contains a list of all the event loops and IP addresses and ports, basically. That was just super performance. Only if you're doing something stupidly big would you really need to do this, but you could. This API can decide which event loop to use, either by doing a round robin, so looping through them one by one and choosing which one, or it could even do that weird ZNQ thing that I showed you before by asking each event loop you've got, how many clients do you have? You return how many clients do you have, and you choose the one with the lowest, and that's the IP import you want to use to use for the event. So once you've chosen your event loop, you then do the usual stuff before, fire off into a queue. Don't forget, you can also scale your queues. So if you're using random queue, you can use that exchange thing that allows you to jump between multiple queues. It doesn't matter because a random worker is going to pick that up. You do its stuff, which takes however long it needs to do, and then send that response back over 0 and queue, which you then broadcast back to the client, which you've already seen. So you can do an inter-processing here really easily. And you can scale your event loops by adding a new one to the database, which immediately becomes a part of the decision-making process when choosing a new event loop. You can even automatically scale these depending on certain things. You can drop or start a new one. And workers are scalable as well, so is your queue. So the whole thing's scalable here. Above all, you already control for the logic of that. So, any newer tech that I tried, and this is more recently, yes, I used Voirt/Throughway. So Throughway is WAMP 2 compliant, so it has nicer interface methods basically. And in this, I didn't need 0 MQ, so I've removed 0 MQ from the stack. We trigger a subscription like before and add to the queue like before, but the workers just connect to WebSockets and just send the information straight back over, which is great. Really easy. I use PHP and QElib, so just apply the same sort of architecture. The workers are completely separate from everything else, and it'll work. Excuse me. But we're still polling for the data on the server, you say. Yes, we've removed the overhead of all the headers and everything for HTTP, so we're not asking all the time, which is great, but we're still asking every 2 or 5 seconds. Guess what? That's not my problem. For real-time data, you have to program a daemon. Daemon programming, I have no idea how to do that properly, which requires yet a different mindset. So this is actually where I'm interested in going next. Because right now, honestly, if I was asked to do a CPU usage example and send that information over WebSockets, my really fast, super shit way of doing it would be Python script that runs top on Linux, passes the output, and then sends that over WebSockets. That's super inefficient. What you're supposed to do, apparently, is, and I copied and pasted this off Stack Overflow, it's not right brain, Use C++ binary queries that host resources, MIB, sleeps on pthread, mutex, whatever the hell that is, and there's threading and all this other crazy shit. So I'm not going to pretend I know I can bullshit that one. But everything at the lowest level is still polling. I'm sorry, that's just how it is. If you're asking an Internet of Things light bulb for its brightness, guess what? All you're doing is subscribing to information for that. It's probably the best way of doing it. And that light bulb itself, on its chip, is still asking its sensor what the light bulb is, what the brightness is every so often, polling it, and then making that information available. That's all it is, polling. So there's no real time, it's just a buzzword. So it's still polling, it's just really fast. We never actually get away from polling, so we only hide it lower down the tech stack, that's all we do. So what I learned from this is using an event loop is not the same as using non-blocking or asynchronous code. In fact, you'll notice, if you're clever enough to do async, of which I'm not just yet, but I'm getting close, is this can use any async. And it's great because you can write your horrible synchronous slow code and it's executed in a worker outside of the event loop, so you don't need to care. That's great. Easiest way to not block is to use a thread or a process if you want to do it on the same machine, which you probably don't in enterprise, or a queue. All connections, you can use SSH with Tor for Torrent if you want to do that anonymous stuff. I kind of went away from the anonymous stuff. You could accomplish this with Node.js, but obviously no one here thinks Node.js is good enough because it isn't. It's crap on the wall, also because we use PHP, yes. I found out towards the end, I could have just made RPC calls to the server instead of doing all this horrible command line shit. Seriously. Right at the end, as is always the case. And I also found out that I didn't have to broadcast, I think, on a specific topic. I think I could just call the method on the connection and it will send information. You'll have to look at the interface methods if you go through this yourself and figure out a way of sending information to the client. And server-side real-time, in quotes, which I should have put on here and I didn't, requires a daemon or threads or all the kind of stuff, which I'm honestly not into just yet. So in PHP, you can use React like I did because it's really simple interface methods, or AMP-PHP, which is more complicated, but apparently way more awesome and way more up-to-date. Same sort of architecture that you can use. Use Throughway, which has the 1.2 spec stuff, and Aries is the Websocket implementation that you use with AMP-PHP. Install libev or libevent if you're on Unix, and libuv if you're on Windows, which I'm not. Where can you go next if you're actually interested with this stuff? If you find this useful and you want to give this a go and go way ahead than I did, then get a simple example working up. I'll put the slides up, I think, or you can just ask me. Use processes first to offload the work. Get 0MQ working and use terminal like I did in one line to send something into the event queue from anywhere. Try with another language. Okay? Use a queue to offload the work, like RabbitMQ instead. It's a really easy to use API. Then, this is where I am now. Move on to actual async. So I'm still trying to do this async stuff in PHP. I've been told that maybe it's easier to go into C# and understand how async works first before trying it in PHP. And enjoy callback help. That's one way of doing it. That's where I'm going to learn next, and then kind of show the pros and cons of this. Everything's a trade-off. And now you know how you could do real-time communication and real-time quotes and sending information over WebSockets, not just triggered by the client, triggered by something else, some other process, and not using Node.js. Thanks for listening. I'm J7Heavy on Twitter. Trivago, which is who I work for, are hiring mid-levels in Palma, Mallorca. Come join my team. It's awesome. I've got my own team. Apparently, we can have unlimited resources. It's a brand new project. And also, it's worth hundreds of thousands of euros. Come work with me. It's going to be ace. Please give feedback for everyone. Some speakers only get to come back to other conferences because they have feedback. Even if it's critical, tell the speaker in person if you want to. I'm happy to take any criticism. I probably will do after this in the Q&A. This is actually the application that I ended up making for me and my friends. I really want to put this on GitHub. I put a crappy version of it. I want to update it. This is just, you can see how it's a nicer UI than the transmission client that I had. Again, no legal stuff. And thanks for listening. Minutes. Okay, shoot. Can't shoot me down. Oh, anyone got anything I can talk about? Any questions? Because it wasn't usually Node.js, I knew it. Anyone? Any questions?
How can you do the authentication of...
Have you got a microphone up there or no? Can you say that again, sorry?
Can somebody else ask? How can you do the authentication of the requests?
Authentication?
Yeah.
So, like I said, with Rapture, there's a sessions handler that allows you to interrupt, like talk to the already sessions that you're already using with HTTP. All I did was recreate that effectively by submitting a user ID and a token to the client, and then you would send that back up and you would recreate the user object, and from then on you've got everything else from there. Well, if you want sessions and shared stuff, then I recommend looking at that, seeing how that looks. I didn't do that. I didn't need to share sessions, but you can do that. It's a solved problem.
Thank you.
Is there any limits on PHP version?
So the question was, is there any limit on PHP version?
Yeah.
I was doing this on PHP 7, so why, do you mean further down? So you want to go to PHP 5.3 or something like that? That's inspiration.
6 or
I'm not going to answer that.
I can answer.
It should be fine. In fact, to be honest, everything's on packages now, so you can go through the packages versions and choose a previous version. Sorry, was the question here?
Yeah. We implemented something like this, and we have a problem with SSL because of the proxy path on Apache. Because every connection is a new thread on Apache server. Is that, I don't know if we are the only one that have that problem? Or?
So the question was, they use SSL, right with it, also because it spawns a new thread on Apache or something, it goes really out of control.
Yes. Because every connection is a new thread.
Because every connection is a new thread, yeah. When I did this, I didn't use SSL, although I know it worked. I probably should have, and if I was doing it in the future I would, but I'm glad I know about that. But I'd probably consider Nginx apparently because it's much faster. I don't want to be one of those people.
Yeah, the connection is a stable connection, is open, so there is a process until the connection goes to the end. And the point is that the connections are always on. There is 100 users, so there is a,
yeah, so if that's the price you pay with SSL, I guess. That's just an overhead you have to pay with SSL, which is really important.
There is no native for Ratchet SSL.
Not that I know of, but you should check out AMP, because AMP is, like I said, a lot more complicated, and I think they're either working on an SSL thing or they have it already. And that's really being worked on by a load of psychological guys who really know this stuff. So you should keep an eye on that. That's a really good question, and I should definitely look at that. I'll need to know that if I ever do this in any client. Any other questions?
We've got the mic.
Excellent.
Feel free.
Okay. Anyone want to use the mic? I think that's it. If anyone wants to talk to me afterwards, to slate me or say something they've done with Websockets, please. I'm really interested in this stuff, so come talk to me. Please give feedback on joined in. Any critique, come tell me in person. And thank you very much.